now, except for to be like, this is how they did it when my grandpa was young. But they have dials on them. They're live meters. I mean, you can read outward voltage with them, and they've got dials. There you go. Julie's logged into the collaborate session, right? Okay. Like I said, I'll just have to remember to show you guys one of the circuit breakers. This is, like maybe a typical fuse box in the car. You can kind of see how this works as far as we've got a bunch of fuses, different fuses in here. Here's like a bigger fuse, bunch of ATC fuses. These are relays, which we'll talk about it a little bit later. And then you've got a bunch of pretty big wires going to the fuse box. So these are, at least one of these wires is going to be coming straight from the battery, from the car's battery to power up the fuse box. Okay? And then a lot of these other wires are probably going out. There's going to be at least one wire that's coming from switched ignition voltage. So when you turn the key on, when you turn the car's key on, that's going to power up a bunch of circuits that were not powered up when the key was off. Like if you go into your car, you can turn the headlights on in most cars without the car on, right? So that's got to have power all the time. Brake lights usually have power all the time too. Most other stuff on your car though, if you don't have the key on, you're not going to be able to turn it on, right? So that stuff would all get powered up through the ignition switch. So basically you turn the key on and then power goes to certain parts of the fuse box, and then certain circuits get powered up only when the key is on. So there's a big difference between constant 12-volt power and key on voltage.
So is a wire connected to each one of them fuses that go to something?
Yeah, usually the fuse box itself is all the fuses would go into a printed circuit board. And then there's wires coming out of the bottom. Yeah, I should go grab them, actually, as long as we're talking about it. That's the only problem about doing stuff in this room versus our room. It's like, should we grab that stuff? Here, I'll see if this video works, and I'll go grab a fuse box. I bet it doesn't work. Click on the plate. Got no sound. Hold on a second. So it might be because we're in this collaborating session. I mean, I already kind of showed you guys how to check fuses, but I do not know why it's not working.
There are several ways to check electrical circuit protection devices, like fuses, circuit breakers,
No
and
clue how I
useful
made that
links.
work.
The most common test methods are a visual check, a test light, and a voltmeter and ohm meter. Most fuses are designed in a way that allows the conducting element to be seen easily. When inspecting the fuse, look for cracks or opens in the element. Also, look for signs of burning. It is important to point out that visual inspection may not always determine if the fuse has an open. And because you can't see inside the insulation, a visual inspection can't be used to diagnose a burned fusible link. To test a fuse with a test light, Begin by connecting the clip of the test light to a known good ground. Next, touch the probe to each end of the fuse. If the light comes on at both ends of the fuse, then the fuse is good. If the light works at only one end of the fuse, it's bad and needs to be replaced. Remember that a blown fuse is an indication that the circuit has been exposed to higher than normal current levels. The cause of this excessive current must be diagnosed and corrected before the job is complete. Testing a fusible link is similar to testing a fuse. You begin by connecting the clip of the test light to a known good ground. The negative side of the battery is best if it can be reached. Next, touch the probe to each end of the fusible link. If the light comes on at both ends of the link, then it is good. If the light works at only one end of the fusible link and not at the other end, it's bad and needs to be replaced. Again, remember that a blown fusible link is an indication that the circuit has been exposed to higher than normal current levels, and the cause of this excessive current must be diagnosed and corrected before the job is complete.
Some pretty sweet
To
music.
test a fuse with a voltmeter, start by setting the meter to the DC voltage scale. Insert the meter leads into the proper receptacles. The black lead is placed in the COM port, and the red lead is placed in the volt-ohm port. Next, connect the black lead to a good ground. Then, touch the red meter lead to each end of the fuse. If the meter reads battery voltage at both ends of the fuse, then the fuse is good. If the meter reads battery voltage at only one end of the fuse, it's bad and needs to be replaced. In order to test a fuse with
Yeah,
a
this is funny.
voltmeter, it needs to be removed from the fuse. Next, set the meter to the on scale. The fuse is good. In order,
I don't know if somebody at Snap-on was just trying to be funny for a while, like in the 90s or whatever. But, you know, our meters say OL when they're, and that means out of limits, right? What do you think OFL stands for?
I don't fucking know.
I think that's what it is.
The fact you didn't correct them on that.
Somebody in Kenosha was playing jokes on us, right? You guys know that's where Snap-on's from, right?
Yeah.
OFL.
to test a fuse with an ohm meter, it needs to be removed from the vehicle first. Next, set the meter to the ohm scale. Touch the leads of the meter to both ends of the fuse. If the fuse is good, the meter will show continuity. If there is no continuity, the fuse is bad and needs to be replaced.
Okay. All right, I brought a few examples of fuse boxes. So you guys can kind of see what's going on with these. And we'll work with like checking fuses and stuff like that in the shop next week. Just basic stuff, but you know what? I mean, I'd be lying if I said that I've never had an electric problem on a car. It's happened before. Got an electric problem on a car, and then you know, it seems like it's something complicated. And I start going down this diagnostic road of checking wires and checking this and checking that, and an hour later you find out it's just a bad fuse. And I feel really stupid. Man, why didn't I check the fuse first? You know, like first things first, sometimes it's easy to overlook that stuff.
Oh, yeah, that was my question. Is it like a typical process to diagnose a car, or get that a station on board?
Yes and no. So here's the thing. A lot of problems, almost every problem that you could have with a car, we can use service information. So we haven't used it yet because we're just kind of doing the basic electric stuff first. We will definitely get into service information next week. We have all data and shop key. Usually, I mean, if you get to an independent shop, they're gonna have probably one or the other, not both, because they cost like at least $150 a month to subscribe to. So if you look in service information, and if you work at a dealership, then you have factory service information, which in theory, all data and shop key are like the service information is copied directly from the factory. Like those companies pay for access to the factory information, and they put it all in their stuff. It's all web-based. But anyway, any problem that you have with the car, especially if you have a trouble code, like if you have a check engine light that's on, you have a trouble code stored. Let's say one of the real common ones, P0300, random misfire. Okay, there's going to be, you look up the code and service information, and there's a diagnostic procedure that you use to what's wrong with the vehicle. So they'll tell you, step one is check for voltage here or whatever. Do you have voltage? Yes or no? If yes, go to step 2. If no, go to step 6 or 16 or whatever. And you go through and you test, do all the tests they want you to. And after each one, it'll say like, did you have this? Yes or no? Do you have check resistance of this thing? And is it between 5 and 50 ohms or whatever? If yes, go to step 10. If no, go to step 20. And maybe step 20 then says replace this part or repair the wire between here and there. Okay, so that's like our guideline kind of a lot of times, especially if it's a problem that we haven't seen before or a system that we're not familiar with as a technician. And guess what? That happens all the time. The good news is if you work at like a dealership especially, you work on one manufacturer and they only sell so many cars, right? So you're going to start seeing pattern failures to the point where if a certain car, certain make and model between this year and that year, if they come in with like whatever complaint or you pull whatever code, it's like, I just did 3 of those last week. So you already pretty much know what the problem ends up being. The first time that you do one though, it's gonna take longer because you're gonna have to make double sure. And I'm not saying you can skip a diagnosis, but if it's problems that you've seen before, it makes it more like bing, bang, boom. I already know exactly what to look for. If you're talking about that diagnostic flow chart where it's telling you all the steps to take, maybe there's this many steps, but you can start pretty much in the middle or at the end even. Just double check that this component isn't getting power, or it is getting power, and then if it doesn't work, it's bad. So, like I said, that's kind of the good thing about working at a dealership. You only got one manufacturer to deal with. Usually you're working on newer cars, because a lot of people don't really take older cars to the dealer. I mean, some do. It depends where you're at. But a lot of people, once cars are out of warranty, they're not going to pay dealership prices anymore because they're higher. They're higher than an independent shop. So, I spent most of my career working at an independent shop where we worked on anything that came in the door, pretty much. We were not turning much away. But at the same time, your clientele and what they drive and stuff. Like if somebody brought in a Ferrari or something, we wouldn't have a scan tool that would work with it. Why would we pay for Ferrari software when we never work on them? So stuff like that, you might have to turn away something like that. But basically, I always thought when I was running a shop, I don't want to turn any work away. Because if I send somebody like, let's say I don't do air conditioning or whatever, because I don't have an AC machine. And I'm like, well, go down the road to the other shop, which is my competition. Like, why would I send somebody to my competition? They're going to try to steal that customer. And I would do the same with sublet repairs. So if they don't do AC, then just the customer, and whether they tell them or not that they did the work or not, and then they would make money off of it anyway. I would do alignments for other shops all the time because a lot of shops don't have. That's a $50,000 investment. A brand new alignment machine and a brand new alignment rack all set up is $55,000. We just did. Yep, we just had them installed in 2 shops, Anderson's shop and Hoffman's shop. Both just got the really nice Hunter alignment equipment and a new rack and a new alignment machine. And it's like, man, I wish I was, when I did alignments, I wish that I had that stuff because it took way longer when I did. But that was, when I was really doing it a lot, that was the early 2000s. Different.
We gonna line our wheels if we need to.
You getting that paper.
Next semester, yes.
Next semester.
Next semester, when you guys get into Anderson's class,
October, session, right?
well, October is the second quarter. So that October is the second half of this semester. That's when we'll still be together and we'll be doing engine controls.
Also, January to March, session.
Yep, January to March, you guys will be doing brake, steering, suspension. So that's everything with brakes, anti-lock, bleeding brakes, all that stuff. Drums, discs, cutting rotors, everything. That, along with suspension, alignments, tires. We have nice new tire machines. They can do low pros.
Said the tire machine, what?
They can do low profile tires. I think maybe bigger than that now.
Let me hear that word.
I used to do them a bunch. Like when 22s were like brand new. I used to do a bunch of those. Most of them balance out for shit.
I was just looking at them.
That's your transmission though too.
Look like some brand new tires. I got low pro tires on my Infiniti.
Oh yeah?
Them come with 20s.
20?
Yeah, on that 45, they come with 20s.
Bigger wheels.
You messed up or
Cause they read the wrong speed because the wheel's too big.
we're getting way off track. It's okay, we're talking about cars, right? If we had a wheel, let's just say. That was this big. That was not very round, so it's gonna make some bad vibrations. And then we had a wheel that was this big. Let's roll this wheel 1 rotation. How far is it gonna go?
Shorter than common.
Right, so I don't know what the circumference of this wheel is, but let's say it goes that far. And then this wheel, if we roll it over 1 time, it's gonna be like way over here,
Right.
right? Just 1 rotation.
Right.
So your transmission and your vehicle speed sensor, like your speed sensor knows, it reads how many revolutions of the output shaft of the transmission. And that's how it tells the speedo and the computer how fast the car's going. It uses the rotation of how many rotations of the output shaft of the trans. But it's programmed to have whatever stock size tires are. So it knows that for each revolution of the output shaft of your transmission, that the car traveled this far, whether it's probably like 2 feet or something. Okay, so for every revolution of the transmission, it knows you went 2 feet, and it kind of divides by the time or whatever and says, now you're doing 60 miles an hour. Okay, so but if every revolution of the transmission, if you put bigger wheels and tires on that now have a larger diameter and therefore a larger circumference, circumference is the distance around the circle, your car is going farther. So is your car going faster than before?
Say it again.
Car, is it?
It's covering more distance for every revolution of the transmission.
But
You're changing your gear ratio too. That's the other thing. That's the other thing people get.
so do it go faster or do it just cover more distance?
You're covering more distance, so the speedometer is gonna say you're going slower than you actually are. And it's gonna be a percentage as far as you're gonna be reading further off the faster you go.
What you said about the gears? They do what?
All right, so the other thing.
Changing the ratio of the gears?
The other thing is, let's just say that, let's say that this was a crank, okay? Like we had like a like a handle, and you tried turning this from the outside, or turning this from here, which one's gonna be easier to turn? The smaller one's gonna be easier to turn, right? It takes more, because there's all that leverage there, so it takes more power to turn this. So essentially, it's gonna be, you're gonna lose off the line power. Your car is gonna be slower off the line, or truck, when you put bigger tires on it. It'll be better at, you'll get better like gas mileage at highway speeds.
But can we fix it? So to like change the ratios?
Sure, I guess if you had like a truck and it had let's say that it had a
The biggest profile.
300 final drive ratio, and if you changed it to like better out of the whole gear, it's like a 433 or something like that. And I don't even sit here talking about gear ratios, because we can talk about that all day long. That's what you'll talk about with Anderson. He loves talking about that stuff. Not that I don't, but it is a long conversation. Basically, yeah, you'll get better gas mileage on the highway with bigger tires. This is essentially having like a shorter gear ratio. But you will lose off of the line power. Okay? Questions? This is like a chalkboard eraser.
You just lose stats, no damage done to the car.
What's that?
Say, like, say your stats change on your car, no damage.
I don't think it would really hurt anything necessarily. It just makes it slower off of the line. But yeah, I mean, you could compensate for that by changing the final drive ratio. Changing the ring and pinion if it's a rear wheel drive car or truck.
Wouldn't it like the fender when you turn into the bigger wheel?
Oh yeah, you're gonna get clearance issues when you start altering ride height, like lowering the car, or when you start, putting bigger wheels and tires in it. Yep. I've been in a shop that was doing a bunch of work on like Donk's cars before, and they had like 30s on them,
Yes, sir.
and they were like,
Mm-hmm.
like the big square body. I don't know if you call them square bodies, but because square bodies I think of the trucks, but like the 80s full size General Motors car, like a Caprice or a Delta 88,
70 up to 70.
stuff like that. And they like notch the frame in. They do all kinds of crazy stuff to do it right. It's really impressive.
No scraping on the rim.
It's a lot of stuff. Big money. Oh, I mean, if you're talking about altering the frame, yeah, that's a lot of work. I mean, cutting it and I don't know if they just weld in a new section or if they somehow bend the rails again.
They double the frame.
But if it's done right, I mean, it's
Double the
impressive.
underbody.
I think it's
Lift
cool.
that bitch up.
30-inch wheel, that's
Shocks,
cool.
knuckles, extreme shocks and strips.
Yeah, you gotta change all that stuff. The whole front suspension has to be different.
Yeah.
To do it right, yeah. It's cool, I think it's cool. At our first car show, second car show, there was a couple of dudes they took the body shop class.
Big young guy.
And they had a couple cars like that they brought here to our car show. Or maybe they were still in college back then, I don't know. Pretty nice cars, actually. Huge freaking cars. From the mid-70s, that's like as big as cars got.
My first car was a 79 Mercedes
Yeah,
with the big boat.
that's a big car.
That's that boat seat.
I remember when I was in
You gotta turn it with me.
Greece, and we had like, I think we had 8 dudes in it. 4 people in the front and 4 in the back.
That was like the same size of trucks in Suburban.
Big,
The inside.
big vehicle. Okay, so just a few examples of fuse boxes, guys. This would be like a fuse box cover. So this is not for any of the fuse boxes I have, but there's kind of a map here that tells you what everything is for. And most of they're for, like a starter relay. So either way, bunch of relays, and then there's fuses in here. So it says, 30 amp wiper fuse, 40 amp radiator fan, 40 amp analog brake pump. So this one's probably under the fuse box because everything, these are pretty big fuses and stuff. Every car is going to have at least 2 fuse boxes. There's always one under the hood, there's always one inside the car somewhere.
In the trunk,
Sometimes you're going to have one in the trunk as well.
Pontiac G6.
Yeah, and the battery's right in the trunk on that car, right? It's like a Cobalt, I think, the battery's in the trunk. Like our Saturn or our HHR. Batteries in the trunk on those. So there's a little fuse box back there. There's still gonna be one under the hood and usually one somewhere inside, whether it's like, usually under the dashboard,
Yeah.
most times. But sometimes the sometimes the car, inside the car fuse boxes are like underneath the back seat of an SUV. Sometimes in the glove box, yeah, the kick panel.
Have, the passenger seat flip up and do it for your wipers or something like that.
Inside,
That's interesting, yeah.
yeah. Well, older pickup trucks, they had the gas tank right behind the seat.
That's.
Like, ah, it smells like gas in here. So here's a fuse box. This is probably from a Chevy truck or Tahoe or something. This is a little more modern anyway, probably early to mid 2000s. So what we're looking at, not everything is in there. Some of these bigger holes here is where like a relay would go. You got your fuses, a couple JK's fuses, a couple ATMs. And then we see this big stud here. It looks like a bolt, right? That's where the battery cable would go that powers up the whole fuse box. Right? So there's these bolts here. And what those actually do, if we look at the other side, those bolts go straight through. And you see all these little terminals here. These are all, do you guys think those are male or female terminals?
Female.
Male, right? So then there would be connectors that go for each one of these bolts. These bolts actually hold the connectors down. Okay, so 1, 2, 3, 4, 5. And then if you look at the terminals on this one over here, try to get at an angle you can see, these terminals are a lot bigger. So this fuse box then, either that goes for higher powered circuits, or this fuse box actually powers up another fuse box. It will be under the hood, go through the firewall, inside the car, under the dash to power up the inside of the car fuse box, or inside the truck. And then if you look here, it's too hard to see with this lighting. Kind of hard to see still, but, and I'll turn the light down so I don't fall asleep, but can you see that this is like green?
Yeah.
Inside of here, there's a circuit board inside. And you can take these apart.
Why would we take them apart?
You shouldn't have to, but it is possible.
Oh, okay.
And they'll get like water underneath them, and then you can, this one possibly was removed for that, because the board, where there's corrosion on the board, but the circuit doesn't work, because the power is not coming out of the fuse box, because the fuse box sides of the fuse, so it's like, well, the fuse is good, right? Why doesn't the circuit work? Let's say it's for the horn, to the actual horn or whatever, but the fuse tests good, so what the hell? To trace that wire back, they gotta find the actual wire. Four boxes bad.
Fuse box can power the other ones, right?
Yeah.
So then there's a fuse box, right?
Mhm.
Then the one that's inside the vehicle that goes from that fuse source to the
the other one, right?
Yes.
Like it's corroded or something like that.
Oh, yeah. Yep. And like I said, that's the only reason you would really take this apart. Like, if we did the diagnosis, we pretty much would know that this was bad, but sometimes it's nice to be able to see what actually happened and prove it. That one's got, see that yellow pen writing on there? That's from a junkyard. So if you took that apart, you'd probably take all the fuses out. That's what this is here. So this one you can actually take apart. I don't know if there's a circuit board in it though. So here, like, we could stick fuses in all of these holes. This would be for bigger fuses here. These would be like ATM. This is where well, here's a stud here anyway. So I don't know, power in, power out, or this is constant 12 volts and maybe ignition 12 volts, either way. This one you can take apart and see what it looks like. So there's all the female terminals, right, that the fuses would plug into. And these. Does it come apart further? Yeah, this one does not have a circuit board, it appears. But yeah, you could even take this apart. It might not go back together. I don't know. We'll see. Oh yeah, no, it's held together by like wires. But this is a fuse box. Look at all that shit. All of those, every single one of these terminals that you see is part of a circuit. So there is a lot of circuits on cars. My Chevy probably has one fuse box, and there's probably like a dozen fuses in there. Most of them don't do anything anymore because it's just kind of a stripped down. I guess, but pass that one around too. That one seems like it's new. Here's a connector that would be used with one of those. Probably not one of the actual ones we got here. I thought I brought in another connector. Maybe not. So this is just an example of a connector that will go to a fuse box. What's that?
It's a lot of wires.
Yeah, and this one's not even, this one's like maybe half full. So all these wires here, if you look at them, most of them are pink. Okay? And so as far as like if you were looking for the pink wire and you found that it goes to this connector, you'd be like, cool, I found the connector. And then you'd be like, oh, like, but there is a way. There's a way to tell. And I'll show you guys this a little bit more in depth later. But every connector has got to have some kind of numbers on it. Or letters. Usually they're like microscopic. When I pass this around, you'll be able to see. Hopefully. If you got good eyes anyway. All along here, there's numbers. So each of these wires goes into a specific spot. Even if all these are just pink, they're probably for different circuits, they might be different things. So I see a number 1 over here. Oh, okay, never mind. It's like 1, and then there's A. So it'll be like 1A or 1B. So going across the top here, there's letters like A, B, C, D, E. So like this wire here, if it's green, is in like row 3, and then A, B, C, D. So 3D would be this green wire. So each of the pink ones, they all do different things. And the way that you could tell would be to look at your wiring diagram, and it would tell you which one you're looking for, and then it would be like, wire 7C or whatever. And you could figure it out that way. And these wires do come out of here. But that's just kind of a typical connector. And honestly, that one's probably a good 10 years old. The wires now, there's more of them and they are smaller. So we have to be very careful when we're trying to work with wires like that. As long as we're talking about wires, this is a engine computer. From a GM body car, so like a 2012 Impala.
It looks basic, but it's intricate, ain't it?
Well, look at all the wires going to it. I mean, that's kind of the thing, is all these wires, this computer does a lot of stuff. But you could actually, the way that you take this apart, every connector on the car, there's two locks. This is to make sure that it's in the right position, the red one. You have to unlock it, press the lock down, and then this whole thing slides over. Then you can take it out, and look how small these terminals are in here. That's why it's super important that these things get put on the right way. That's why it has all these channels and levers that we're dealing with.
So these screws and bolts, right? That's
I think those studs on the end, the silver studs there. Yep.
so that's on this ground for the rest of these to get their power
It would probably be a power wire goes to it.
right here.
And yeah, and then if you flip it over, the ones with the bigger, one of those is probably ground.
So when the power comes to the fuse box, it's sending through these, and then these.
Well, they'll just send the power back out to whatever circuit it goes to.
Right.
And if too much amperage is drawn, then the fuse will pop.
Okay.
Yep.
Yeah.
There you go. Oh, did we miss the middle row?
Oh.
Then I'll get to you. Hold your horses. Okay, questions about this?
Question about fuses.
Anything?
Is it?
That's pretty much explained it.
I don't know if you can.
Good. Oh, one more
In
thing.
a way that,
I'll pass around a circuit breaker too, I promise.
Is
And
it
I mean, this thing
is it a fuse that'll make the car stop starting?
I mean, there's a ton of reasons that a car might not start for, but anything to do with like security or theft.
Security.
Yep, if there's a fuse for that system, then that would make it not start.
What?
There's like an
It's a
ignition
fuse for
fuse.
security?
What?
It's a fuse for security?
It's gonna be different for different cars.
Some anti-lock system?
Anti-theft, yeah, anti-theft. Would make it not start. If the car doesn't recognize the key that you're using, you know, if there's a fuse for that computer or whatever and that's blown, then it's not gonna be able to give a signal to the engine computer to say like, oh, that's cool, you can start the car.
Is it like could you manually do it? Like manually pull the lever forward out of the anti-lock?
I mean, the way that anti-theft stuff works, as far as like recognizing the key goes, the key sends out a radio frequency signal, and then it gets received by the computer. So it's not like a lever or something, it's, the computer needs to see the right signal from the key in order for it to start.
Okay.
So like I said, the key is literally a radio frequency transmitter. Like it's like an FM radio or AM radio station, kind of. It's an RF signal, and then there's a computer that receives that RF data, radio frequency. Yep, and it needs to send out the correct signal.
So it's a chip, even if it's old school kind of key, it's a chip in there?
That one probably doesn't have a chip, but some of these old GM keys did. And that was different, it was just a chip, it had a resistance in it. And then when you put it into your ignition switch, there was two wires that would go through it and it would measure the resistance, and it needed to be the right resistance, otherwise it wouldn't start. And I worked at a GM dealer when we had keys like that. And there were these two little wires, and they would break all the time when they would go through, I'll get to you in a second, but they would go through the steering wheel, right? If the key was in the column, they go through
What's
the
this,
column, it
another
was a
fuse?
tilt column. So from tilting the wires, they would break when the car wouldn't start. They're teeny little yellow wires. But the
kind of just answered it. I was just gonna say, when I was working, I tried to turn it, it broke, and the car was,
Oops,
so was that, because like, something like,
the key broke.
yeah, like, so it was a fob,
Yeah.
like, it had buttons, and all that, it wouldn't start.
I guess it depends what kind of car it was.
And it was a-
You're applying too much force.
Yeah, it's not 100% sure.
It's not second on the
It
key.
was already.
It's interesting, it came out knock. And you put too much force into it. Turn it on. Huh?
It might have been, oh, here was it from? Remember? Here, was it from? It's probably-
I have a knock.
Okay. Yeah, it might have been. I mean, there's like there's
On the
a,
other room, so it's like, like, bent it.
there's resistors and stuff like that. So it probably had something in it where the key needs to be programmed to the car. The new ones, like the fobs have a battery in it, because if you have an RF signal that gets sent out, it needs to have power. Same thing with, that's how your tire monitor system works. There's a sensor inside of each wheel that has a battery in it, like a watch battery, and it senses the pressure, and it sends out a signal, a radio frequency signal. So you basically have like 4 radio stations, like one on each wheel.
On to the dashboard, when it's.
It sends it to a receiver module,
Okay.
which receives the signal, and that, if one loses pressure. That key fob probably has got a battery in it. It sends a signal out. And you can change the battery in there,
So then if mine don't got a key,
Yeah,
or if
yeah,
the car
yeah.
doesn't have a chip in her key, that means they got a lever then? Or is it still the 2 wires, they get the
Big battery.
signal?
I mean, if you just have an old school key like this, it's just a chunk of brass.
Hey, youngin,
Battery, yep. Like this is an ignition switch that, yeah, like old ones, press it, literally, the lock still, power goes out to the starter, pretty much. And then it turns the engine over. But anyway, I mean, we can keep talking about that for a long time. Pretty much time for lunch. I mean, a little early.
we gonna be making these wires too? Like, connecting the ends and all that. Starting them
Yes.
together and,
Yeah, I was kind of trying to decide when we would do that.
so you know how they got that little metal.
Best
thing
if we
up
do
there?
it in the shop.
No, they got these on there.
Oh, yeah, yep,
We gonna be connecting them too.
oh, yeah. Yeah, we've got drivers for stuff like that, and then we will work
Yeah, that's
with
what it's called.
removing the terminals. Those are the ends of the wire.
The
The
wire in
terminals.
there, crimper to tighten it on there
And there's a special crimper you use for those.
for each one.
They're probably all the same for each wire. Some of the terminals might be different, but
What terminal? What's that?
the metal end. Yeah, and they come out of there too.
Yeah, no, I just think.
You need to special take it out with a little screwdriver. So this little thing locks them in, but then they're still locked in. If you notice, if you look at it straight on, see how it's like a square, but there's a little nub on that side. That locks the wire in. So if I just try pulling it, if I just try pulling it out now, it's not gonna go. But you might, I don't have the right tool for it, but I might be able to get one out with this. Or I might just demolish this thing. Oh, there we go.
Nasty.
Yep, yeah, we've got the exact crimpers that do this.
Okay.
Yeah, so we will work with that stuff next week. For sure, yeah.
Oh, really?
See if I can remember how this went. Losing,
Oh, really?
clicks in. All right, gentlemen, why don't we break for lunch a few minutes early and meet back here at 12:30, okay? I'm gonna lock this room, yeah. I'll try to open it a little before class starts. Leave.